The interpretation regarding the use of underground service entrance or use cable inside a building is correct. Use cable is indeed not permitted for indoor use because it lacks the necessary flame retardant properties required by electrical codes for interior wiring. Putting the use cable inside conduit will not make it compliant because the conduit does not render the use cable flame retardant. Conduit provides mechanical protection, but it doesn't change the inherent flame retardant characteristics or lack thereof of the cable itself. The solution involves replacing the existing use cable runs with appropriate cable types that are specifically listed and suitable for indoor use. Acceptable alternatives include conductors such as THHN, THWN, or XHHW. These cable types have insulation that is flame retardant and meet the requirements for installation inside buildings. The specific length of the cable runs, whether they are 40 or 50 feet, is not the primary concern. The critical issue is the cable type itself. The entire length of the use cable within the building must be replaced with an approved cable. Here is a breakdown of the reasoning and code considerations. Firstly, electrical codes, such as the National Electrical Code, or NEC, set minimum safety standards for electrical installations. These standards are designed to protect people and property from hazards such as fire and electric shock. Secondly, one of the key aspects of electrical safety is the proper selection and installation of wiring and cabling. Different types of cables are designed for specific applications and environments, and they have different properties such as insulation type, temperature rating, and resistance to moisture and chemicals. Thirdly, flame retardancy is an important property for cables used inside buildings. In the event of a fire, flame retardant cables will resist ignition and slow the spread of flames, providing valuable time for occupants to evacuate and for firefighters to respond. Use cable is designed for direct burial in the earth or for installation in underground raceways. It has moisture-resistant insulation, but it is not required to be flame retardant. This means that if use cable is exposed to a fire inside a building, it can easily ignite and contribute to the spread of the fire. The NEC specifies the types of cables that are permitted for use in different locations and applications. For indoor wiring, the NEC typically requires cables that are listed and labeled as being flame retardant. Examples of such cables include THHN, THWN, and XHHW. THHN stands for thermoplastic high heat resistant nylon coated. THHN is a type of building wire that is commonly used for general purpose wiring in residential, commercial, and industrial buildings. It has a thermoplastic insulation with a nylon jacket which provides good resistance to heat, moisture, and abrasion. THHN is typically used in dry locations, but it can also be used in wet locations if it is installed in conduit. THWN stands for thermoplastic heat and water resistant nylon coated. THWN is similar to THHN, but it is also water resistant. This makes it suitable for use in wet locations such as bathrooms and kitchens, even without being installed in conduit. THWN is also commonly used for underground wiring. XHHW stands for cross-linked polyethylene high heat resistant water resistant. XHHW has a cross-linked polyethylene insulation which provides excellent resistance to heat, moisture, and chemicals. XHHW is suitable for use in both dry and wet locations, and it is often used for underground wiring and for direct burial applications. When selecting a cable for a particular application, it is important to consult the NEC and to choose a cable that is listed and labeled for that use. It is also important to follow all of the manufacturer's instructions for installation and to ensure that the cable is properly supported and protected. The NEC provides detailed requirements for the installation of cables, including the type of conduit or raceway that is required, the spacing between supports, and the methods for terminating the cable. If use cable is installed inside a building, it is a violation of the NEC and poses a significant fire hazard. The correct course of action is to remove the use cable and replace it with a cable type that is listed and labeled for indoor use. This will ensure that the electrical installation is safe and compliant with the code. The decision to replace the use cable with an approved type is not just a matter of code compliance, it is a matter of safety. By using the correct type of cable, the risk of fire and electric shock can be significantly reduced. Here's a more detailed explanation of why use cable is unsuitable for indoor applications. The primary reason use cable is not permitted indoors stems from its lack of flame retardancy. This characteristic is crucial in preventing or slowing the spread of fire within a building. Interior electrical wiring must be able to resist ignition and limit flame propagation to provide occupants time to evacuate safely during a fire. Use cable's construction prioritizes moisture resistance for direct burial applications, but it does not meet the flame retardant standards required for indoor environments. Enclosing use cable in conduit does not compensate for its lack of flame retardancy. While conduit offers mechanical protection to the cable, shielding it from physical damage, it does not alter the cable's inherent flammability. If a fire occurs, the use cable within the conduit will still ignite and potentially contribute to the fire's spread, negating any protective benefits the conduit might offer. To ensure electrical safety and code compliance, use cable must be replaced with approved cable type specifically designed for indoor use. THHN, THWN, and XHHW are common examples of such cables. These cables feature insulation materials that are flame retardant, meaning they resist ignition and slow down the spread of flames. This is a critical safety feature for indoor electrical wiring. The choice between THHN, THWN, and XHHW depends on the specific application and environmental conditions. THHN is suitable for dry locations, while THWN is designed for wet locations. XHHW offers excellent resistance to heat, moisture, and chemicals, making it versatile for various environments. When replacing the use cable, it is essential to adhere to all applicable electrical codes and regulations. This includes selecting the correct cable size and ampacity for the intended load, properly terminating the connections, and ensuring that the installation meets all safety requirements. The length of the cable runs is not the determining factor in whether or not the use cable is compliant. Regardless of whether the runs are 40 feet or 50 feet long, the use cable must be replaced with an approved cable type for indoor use. The focus should be on ensuring that the entire electrical system is safe and code compliant. In summary, use cable is not permitted for indoor use due to its lack of flame retardancy. Enclosing it in conduit does not make it compliant. The correct solution is to replace the use cable with approved cable types such as THHN, THWN, or XHHW, ensuring that the entire installation meets all applicable electrical codes and regulations. Doing so is essential for protecting people and property from fire hazards. Consider the National Electrical Code, specifically Article 310.15, which addresses ampacity of conductors. This section provides guidance on determining the allowable ampacity of conductors based on factors such as insulation type, temperature rating, and installation conditions. When replacing the use cable, it is important to select conductors with an appropriate ampacity rating to ensure that they can safely carry the intended load. Additionally, Table 310.16 in the NEC provides ampacity ratings for various conductor sizes and insulation types in different installation conditions. This table can be a valuable resource for determining the correct conductor size for the application. Furthermore, consider the requirements outlined in Chapter 3 of the NEC, which covers wiring methods and materials. This chapter provides detailed information on the types of cables and conductors that are permitted for use in different locations and applications. It also includes requirements for the installation of wiring, such as the type of conduit or raceway that is required, the spacing between supports, and the methods for terminating the cable. Additionally, Article 300.3, which addresses conductors, requires that all conductors of a circuit, including the neutral and grounding conductors, be installed in the same raceway cable or enclosure. This helps to ensure that the circuit operates properly and that there is a lower impedance path for fault current to flow back to the source in the event of a ground fault. It is important to consult the NEC and to follow all of the requirements for wiring methods and materials to ensure that the electrical installation is safe and compliant with the code. When selecting conductors for an electrical installation, it is important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidance on calculating voltage drop and recommends that voltage drop should not exceed 3% for branch circuits or 5% for feeders. There are several factors that affect voltage drop, including the length of the conductor, the size of the conductor, the current flowing through the conductor, and the type of conductor material. To minimize voltage drop, it is important to use conductors that are large enough for the intended load and to keep the length of the conductors as short as possible. In addition to the NEC, there may be local electrical codes or regulations that apply to electrical installations in a particular area. It is important to be aware of and comply with all applicable codes and regulations to ensure that the electrical installation is safe and legal. Here's more on flame retardancy. Flame retardancy refers to the ability of a material to resist ignition, slow down the spread of flames, or self-extinguish after being exposed to a heat source. In the context of electrical cables, flame retardancy is a crucial safety feature that helps to prevent or minimize the spread of fire in the event of an electrical fault or other ignition source. Flame retardant cables are designed to resist ignition and to limit the amount of smoke and toxic gases that are released during a fire. This provides valuable time for occupants to evacuate the building and for firefighters to respond. There are several different standards and tests that are used to evaluate the flame retardancy of electrical cables. One common standard is the Underwriters Laboratories or ALL VW-1 vertical wire flame test. This test involves suspending a sample of cable vertically and exposing it to a flame for a specified period of time. The cable is considered to pass the test if it does not ignite or if it self-extinguishes within a certain time frame. Another common standard is the Institute of Electrical and Electronics Engineers or IE 383 flame test. This test is more rigorous than the ULVW-1 test and is used to evaluate the flame retardancy of cables that are used in nuclear power plants and other critical applications. In addition to these standards, there are also various European standards for flame retardancy, such as the EN 60332 series of tests. These tests are used to evaluate the flame retardancy of cables that are used in Europe. The specific flame retardant requirements for electrical cables vary depending on the application and the location. However, in general, cables that are used inside buildings are required to be flame retardant to some degree. This is to help prevent or minimize the spread of fire in the event of an electrical fault or other ignition source. Flame retardant cables typically contain additives that help to resist ignition and to slow down the spread of flames. These additives may include halogenated compounds, such as chlorine or bromine, or non-halogenated compounds, such as phosphorus or nitrogen. The choice of flame retardant additives depends on the specific requirements of the application and the desired performance characteristics of the cable. In addition to flame retardant additives, some cables also have a flame retardant jacket or coating. This jacket or coating provides an additional layer of protection against fire and can help to further reduce the risk of fire spread. It is important to select cables that are listed and labeled as being flame retardant for the intended application. This will help to ensure that the cables meet the applicable safety standards and that they will provide adequate protection against fire. Here's information about cable markings. Electrical cables are typically marked with various information to identify their type, size, voltage rating, and other characteristics. These markings are important for ensuring that the correct cable is selected and installed for a particular application. The markings on electrical cables are typically printed on the outer jacket or insulation of the cable. The markings may be printed in a continuous manner along the length of the cable, or they may be printed at regular intervals. The specific markings that are required on electrical cables vary depending on the type of cable and the applicable standards. However, some common markings include the following. The cable type is a designation that identifies the type of cable, such as THHN, THWN, or XHHW. The cable size indicates the cross-sectional area of the conductors in the cable, typically expressed in American wire gauge or AUG. The voltage rating indicates the maximum voltage that the cable is designed to withstand. The manufacturer's name or trademark identifies the manufacturer of the cable. The listing agency mark indicates that the cable has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories, or all. The temperature rating indicates the maximum temperature that the cable is designed to withstand. Other markings may include the cable's flame retardant rating, its moisture resistance rating, and its chemical resistance rating. It is important to be able to interpret the markings on electrical cables to ensure that the correct cable is selected and installed for a particular application. The NEC provides guidance on the markings that are required on electrical cables and on how to interpret these markings. In addition to the markings on the cable itself, the cable may also be accompanied by a datasheet or other documentation that provides more detailed information about the cable's characteristics and performance. It is important to review this documentation before installing the cable to ensure that it is suitable for the intended application. Also keep in mind the specific requirements for electrical installations in a particular area. It is important to be aware of and comply with all applicable codes and regulations to ensure that the electrical installation is safe and legal.